All right, this is the Algebra 1 Unit 6 Lesson 8 video. And again, we're in this string of lessons where we're learning to solve quadratic equations using different methods. And this method, using square roots, is kind of a special method used when your function that you're looking at is made up of only the ax squared and the c term. Remember, this is our standard equation right here. But in this example, there is no bx. There is only ax squared and c. And so there's kind of presents a unique opportunity to solve this equation using square root. So it's very simple. You are going to get this by itself. So to do that, we're going to first add 9 to both sides. X squared equals 9. And then we're going to then do the real kind of focus of this lesson, which is we are going to take the square root of both sides of this equation. In other words, we're going to do the square root of x squared and the square root of 9. And you should know when you square root and squared are inverses of each other. So when that happens, what's really going to happen is that they are going to cancel each other out, leaving us with x equals, and then the square root of 9 is 3. But actually we need to pause here because actually something we have to understand about square roots is that, especially when we're dealing in algebra, we need to understand that also the square root of 9 is negative 3. You might be thinking, well, how's that possible? Well, it has to do with the fact that both 3 squared and negative 3 squared give me an answer of 9. Because a negative times a negative, and that's what squaring does, is a positive, it also equals positive 9, which is why we need to have both of these solutions. And that's why you'll see in the lesson the answer being written with that notation, plus or minus of that number. So in general, this is how we're going to solve this. But I wanted to show you real quick. If I go over here to Desmos and I put in x squared minus 9, I can see, just like I told you, that we have positive and negative 3 as our solutions, which corresponds to what I found when I did it algebraically. So you can always take your equation and put it into the Desmos system and look at the solutions if you'd like. But in general, I'll kind of go through the steps again. You need to make the equation, whatever form it is in the beginning, you need to get it so that x squared is by itself. So you need to isolate x squared. That's step 1. And then square root it. Those are your kind of 2 basic steps in this process. Now, number 1, that's pretty much straightforward like we just got done doing. Number 2, obviously, that 2 needs to be dealt with. So you need to use algebraic methods to get that 2 out of there, therefore getting you to that point where you have x squared by itself. So you need to figure out how to do that. Use algebra to do that. I think you know how to get rid of that 2 since it's being multiplied by x squared. Actually, I'll just go and talk about that. 2x squared equals 800. Well, if I want to get rid of that 2, I'm going to do the opposite, which is divide. And so I end up with x squared equals 400. And then I can do the square root of both sides. And I'll let you figure it out from there. Similar stuff in some of these other problems. Number 3, you don't really need any help there. Number 4, you can see here that we've got some answers that are in square root form. If you take the square root of 27, you will not get a whole number. Let's jump over here and just do that. Square root of 27 is 5.19. Okay, so how do I know which answer choice corresponds with that? I'm going to type these answer choices in and see which one gives me the correct response. So like 4 square root of 3. 4 square root 3 is 6.92. That is not the same number. So that one can't be the answer. So I would say first that that is not the answer. So I can keep doing that. 5 square roots of 3. Sorry about that. 5 square root 3. 8.66. Also not the answer. And I'll let you finish that out. So you verify that the square root of 27 equals one of the answer choices that you've got on that problem. So you'll have to kind of go through and do that. More of the same in number 5. And then number 6, I will post this in the notes, but the formula for finding the slope of a line is m equals x2, I messed up, let's go back, y2 minus y1, x2 minus x1. This is x1, y1. This is x2, y2. So you'll do 5 minus 3 on the top, 2 minus 1 on the bottom, and then solve it out. Same thing with number 7. Those are those review questions we've talked about. But I will post the formula for the slope of a line in the notes. And again, that should be a review, but I will pause actually, and I will do one example of that in the second part of this video.